Hello guys, you're welcome to today's class. This is chemistry JAMB class. And I want to believe you guys are fine today. Okay, we're going to be using this question as a guide for today's class. So subsequently too, we are going to be using it. Number one, it will afford us to knowing how to answer JAMB questions, and not only that, it will allow us to be able to answer it correctly, having known a whole lot of things about that very particular topic. So we are starting, and I want to believe you guys are ready for the class. So let's see, we are going to be using this question as a guide. So let's see the question we have here. Number two is saying, which of the following is an example of a mixture? A, common salt; B, blood; C, sand; D, washing soda. Which of the following is an example of a mixture? A, common salt; B, blood; C, sand; D, washing soda. Now, before you answer any question as Jambite, let me quickly give this warning. You need to know the topic they brought that very particular question from. If you are able to do that, it will afford you a whole lot of confidence, okay, and it will give you an insight of what the correct answer is supposed to be. So before you answer any question, please understand the question and deduce the topic that brought that very particular question from. The topic they brought that particular question from will still be from our normal JAMB syllabus. So we're going to be analyzing this question before we now answer the correct, before we choose the correct answer here. We analyze this very particular question to see which one is the correct answer. So out of the JAMB syllabus, which of the JAMB syllabus do we have this very particular topic, and where did they bring this very particular question from? The topic is called pure and impure substances. That's where they brought it from, and that's what we're going to be looking at in today's class. Pure and impure substances. Okay, very quickly, as chemistry students, we must have been taught matter in school, which is, that is the basics of chemistry, or that's what chemistry is all about. We must have been taught matter. Okay, and from our normal class, from our, preliminary class, they will always tell us matter is anything that has mass, okay, has mass and occupy space. Okay, we are familiar with that. So, say matter is anything that has mass and occupy space. Very correct. Now, and we know that our state of matter, say the state of matter is divided into solid, into liquid and gas or gaseous. We know all that already. But having known all this, our matter on a broad basis can still be subdivided into pure and impure substances. Having known all those definitions of matter and the state, it can still be subdivided into pure and impure substances. So everything regarded as matter on a broader basis can be classified into two. One, pure substances. Two, impure substances. I want to believe we are following, and I want to believe we are paying attention. Now, to a chemist or in chemistry, what do you mean by pure substances? What do you mean by pure substances? In chemistry, what do you mean by pure substances? To a layman, it'd be like pure substances are something that is clean, or pure substances is what is free of dirt, or pure substances is what doesn't have impurities. In chemistry, pure substances are not defined like that, because you'll be surprised that what you think is pure substances to a layman is not pure substances, and what you think is impure, as a layman, is not actually impure. So if something is pure, what do we mean by that, or how do we know that something is pure? Number one, if something is pure, it means that it contain it contain one type of atom or particles. If something is pure, it means that it contains one type of atom or particles. I am going to explain that. It means that it has a definite composition. If something is pure, it means that it has a definite composition. 3, it means that it cannot be separated. It cannot be separated by physical means. It cannot be separated by physical means. Why? 4, I said 1, contain one type of atom or particles. 2, it has a definite proportion. 3, it cannot be separated by physical means. 4, they have sharp melting and boiling point. Sharp melting and boiling point. Okay. So if something is pure, it means that number 1, it contains one type of atom or particles. Number 2, it has a definite composition. Number 3, it cannot be separated by physical means. Number 4, they have sharp melting and boiling point. So let me give an example, and I'll be explaining that example based on the characteristics of this pure substance I gave. So let's look at H2O as matter, which is water. H2O as matter, and we know that that is a familiar compound, that is normal water in the liquid state. Okay, now is water a pure substance? That's the question. So we're going to be looking at it in these 4 headings. Number 1, we said it contains one type of atom or particles. Okay, do water contain one type of atom or particles? Definitely yes. Definitely yes. Why am I saying why am I saying that? If you look at water now, if you want to actually call this, you say you have 1 molecule of water. The reason is because all the particles here are particles of water. Despite that you have it to be H2O, which is telling us that you have hydrogen and oxygen. This hydrogen and oxygen are acting as one. They are acting as one. Okay, this hydrogen is not acting alone, this oxygen is not acting alone. The two of them are acting as water because they are chemically combined together. So these particles here, or this atom here, are, we can say it is molecule of water, okay, or we say they are atoms of water. So it contains one type of particles because all what you have here are atoms of water because they are chemically combined together, and this very particular hydrogen and oxygen are acting as one. I don't know if you're getting this. So very, very important. All what I have here are atoms of water or particles of water. So it means that it fills the first criteria, which is what it contains one type of atom or particle. Number 2, it has a definite composition. Yes, you cannot write water as H3O. No. For everybody, that understand water, we know the molecules of water are 2 atoms of hydrogen and 1 molecule and 1 atom of oxygen. Anything different from this means that you have not written the molecular formula of water. If you write it like this, it means you have not written water. So because, and why is we having 2 molecules of hydrogen and 1 atom of oxygen? Because it is fixed. Every Tom, Dick, and Harry knows the molecules of water as 2 molecules of hydrogen and 1 atom of oxygen, or we say it has 2 atoms of hydrogen and 1 atom of oxygen. Anything different from this means you have not written water, and the reason is because it is definite. Their composition is definite. In what sense? 2 atoms of hydrogen, 1 atom of oxygen. So meaning water to fulfill the second criteria, which means it has a definite composition. 3, it cannot be separated. I'm here now. It cannot be separated by, so what has fulfilled this criteria? What has fulfilled this criteria? Okay. Said 3, it cannot be separated by physical means. Yes, if I give you water or I bring some water in a glass cup for you and I ask you to separate the hydrogen from the oxygen, it's practically not impossible for you to do that physically because they are chemically combined together. And for everything that is chemically combined together, Everything that is chemically combined together, for any substance that is chemically combined together, you cannot separate them by physical means. Anything that is chemically combined together can only be separated chemically. But here, for you to separate them physically, it is not possible. So the molecules of water here, you cannot separate them by physical means. So water fulfill the third criteria. Why the last one said they have sharp melting and boiling point. They have sharp melting and boiling point. Of course, we know the boiling point of water. The boiling point of water is 100 degrees Celsius. Okay, so any boiling point that is different from this means the water has contained some foreigners, and those foreigners is what we actually call impurities. If I put some quantity of salt in water, it will not boil at 100 degrees Celsius again, because it is not only water that is there. You now have salt in that very particular combination, okay, which now makes it to be impure, because it is not containing one type of atom or particle again. In a place where you have water and you have plus salt, this is not containing one type of atom or particles again. Then you now have atoms of water, you have atoms of sodium chloride. So that's different. So if you put some amount of salt in water, it will not boil at 100 degrees Celsius again, which is telling us that there is a kind of impurity in that very particular water. There is a foreigner in that water, because it is not containing only the particles of water. You get that now? But if there is no impurity there, you are boiling only water, it is going to boil at 100 degrees Celsius. Anything above that or below that means that there is a sort of impurities there. So that's the reason why we said they have sharp melting and boiling point. So for everything that we regard as pure substances in chemistry, they must have these characteristics. They must contain one type of atom or particles. They must have a definite composition. They cannot be separated by physical means. Yes, they cannot. Let me write it so that they cannot be separated by physical means, and they have sharp melting and boiling point. So those are the characteristics of what is pure substance. Let's take other examples. Let's see other examples. Let's take, for example, I have alcohol, which is ethanol. Let's take, for example, I have ethanol. Ethanol molecular formula is C2H5OH. Is ethanol a pure substances? Let's go to the characteristics. You said it contains one type of atom or particle. Yes, because all the atoms here are atoms of ethanol. You don't have any other thing. Despite the compounds here contain carbon, hydrogen, and oxygen, they are chemically combined together. And when they are chemically combined together, they will be acting as one. I hope that is clear. When they are chemically combined together, they are not, they are not in that very particular substances as one, as different elements. They are there as one single compound. And the name we will be calling them is one molecules of ethanol. We are not going to say one, two molecules of carbon, five molecules or atoms of hydrogen. No, they are now chemically combined together. So they are acting as one. So this ethanol here has one type of atom or particles. It has a definite composition. Yes, for everybody that wants to write ethanol, we know you have two atoms of carbon, five atoms of hydrogen, one atom of oxygen, and another atom of hydrogen, which makes it six atoms of hydrogen. So anything different from this means you have not written ethanol, because the reason why we said anything different from this you have not written ethanol is because the compositions are definite. So for ethanol, we are going to have two atoms of carbon. Okay, we are going to have five hydrogen plus one, that's six. So we have six atoms of hydrogen. We're going to have six atoms of hydrogen, and we are going to have one atom of oxygen. I hope that is clear. So for this, we said the composition is definite. Okay, the composition is definite. So we we actually say it is what? It is pure substance. I hope this is clear. So it is pure substances. Now, for the third one, they cannot be separated by physical means. Yes, if I give you some quantity of ethanol in a glass cup, of course you cannot separate the carbon from the hydrogen from the oxygen because they are chemically combined together. And I've said that for everything that is chemically combined together, you cannot separate them by physical means. So meaning it fulfills the third criteria. Why the last one saying they have sharp melting and boiling point? Yes, the boiling point of ethanol is around 78 degrees Celsius. Can you see that? 78 degrees Celsius. Any boiling point higher than this or lower than this means the ethanol is now what? Is now containing some impurities, which means you don't have only the ethanol there again. It's now containing some kind of impurities. That's the reason why it will not boil at 78 degrees Celsius. So if it boils at 78 degrees Celsius, it means it is pure substance. So your ethanol is also a pure substances. I hope you are following. Now let's take another example. Let's take likes of oxygen gas. Oxygen gas a pure substances? Yes, because this oxygen gas, it contains one type of atom or particles. All the particles you have here are particles of what? Of oxygen. So oxygen too is what? It fulfill criteria number one, which is what? Contain one type of atom or particles. It has a definite composition. Yes, for everybody that want to write oxygen molecule, you write as O2. Anything different from this means you have not written oxygen gas. So it has a definite composition. Okay. You cannot separate this oxygen by physical means. If I give you, you cannot even, because oxygen is a gas. Okay. So you cannot separate oxygen gas by physical means. Why? Because these things are chemically combined together. And when they are chemically combined together, you cannot separate them by physical means. And your oxygen, when liquefied too, has its boiling point, which is what? Which is definite. So which means that oxygen too is a pure substances. So it means that from this example, you see, I gave examples of compounds, I gave examples of elements. I hope you are following. Which means that all pure substance, all pure substances, okay, all pure substances will be classified into what? Elements and what? And compounds. Which means that all elements are pure substances and all compounds are pure substances because they are going to fulfill that criteria. Okay, so for all elements, be it oxygen gas, be it hydrogen gas, okay, be it nitrogen gas, okay, be it copper, be it iron, be it gold, be it silver, I'm writing their symbols, all of them are pure substances because they contain one type of atom or particles and they fulfilled all those criteria. So all elements are pure substances, all compounds are pure substances. Let me repeat that again. All elements are pure substances, all elements are pure substances, all compounds are pure substances. So for you to remember pure substances, when you remember any element, you know it's pure substances. When you remember any compounds, you know it's pure substances. And that's the reason why even the definition of an element, if you remember in our preliminary chemistry classes, they'll tell you that elements, they'll tell you that elements are substances, elements are substances that cannot be broken down. It cannot be broken down. Okay? It cannot be broken down into simpler units. Can you see that? It cannot be broken down into simpler units. Okay? Those simpler units by an ordinary chemical process. Ordinary chemical process. Can you see that? So that's the definition of element. So any element we have about around 100 plus elements. So for all elements that they are pure substances. Why for compounds? When you talk about compounds, you are talking about combinations of two or more elements. So when you combine two elements together, you get compound. That's why you have water. So you are combining hydrogen and oxygen together. So that's a compound. You have ethanol. You are combining carbon together with hydrogen with oxygen, that's giving us a compound. Okay, sodium chloride, that's our normal table salt atom. You have sodium, you have chlorine, so these are compounds. So where you have two or more elements combined together, then we say that it's a compound. So don't forget, for all pure substances, all elements are pure substances, all compounds are pure substances. I hope that is clear. All elements are pure substances and all compounds are also pure substances. So think about any element, it's pure substance. Think about any compound, it's what? It's a pure substances. Okay, moving from that, let's go to impure substance. What are impure substances, or how do you know a substance is impure? Number one, is just like the opposite of your pure substances. They do not contain one type of atom or particles. They do not contain, they do not contain one type, of atom or particles. Okay, that's number one. For pure substances, they do not, for impure substances, they do not contain one type of atom or particles. For impure substances, two, they have indefinite composition. They have indefinite composition. They have indefinite composition. Number three, number three, they don't have constant melting or boiling point, or I'll say they don't have, they do not have sharp melting, melting and boiling points. I'm still going to explain them. Boiling point. And the last one, they can be separated. They can be separated. They can be separated by physical means. They can be separated by physical means. So these are characteristics of impure substances. These are characteristics of impure substances. So for you to know impure substances, they will have these very particular characteristics. So they do not contain one type of atom or particle. Let me give an example now. I have water, okay? I have water. I now mix it with salt. Look at this. This is an impure substance because it do not contain one type of atom or particles, because here now you have atoms of water or molecules of water and you have molecules of sodium chloride. So here now you have two different kind of atoms, which are atoms of water or molecules of water and molecule of sodium chloride. So this is one of the characteristics of an impure substance, because this that you have two kind of particles there. Their compositions are indefinite. Yes, their composition are indefinite because for this very particular amount of water, you are putting a quantity of salt in water. You are putting a quantity of salt in water. In some, you might decide to put 2 grams of salt in water. You can decide to put 1 gram of salt in water. You can decide to put 3 grams of salt. It's not definite. It's not definite. So their compositions are what? They are indefinite because it is not stable. In some salty water, like sea water now, you go and test sea water now, you will see sea water is salty, right? Sea water is salty, meaning you have water there and you have salt there. Okay, unlike you tasting another water that I just put little amount of salt there. If you look at that one now, it will be less salty than seawater. And that's the reason why we know their compositions are indefinite. Because if their compositions are definite, it means that the way you have salt in seawater should be like that for any water and salt that you know. But no, it is not possible like that. You get that? It's not possible because their compositions are not definite. So it means that even seawater is an impure substance. Imagine Seawater is an impure substance. Yeah, seawater is an impure substance. Why? Because it do not contain one type of atom or particles. It doesn't have definite composition, and it will not have sharp melting and boiling point, because if you boil that seawater, it will not boil at 100 degrees Celsius. You know why? Because you have salt and you have water there. So the salt is acting as the impurity now. The salt there is acting as the impurity. So water will not boil at 100 degrees Celsius. And they can be separated by physical means. Yes, when we get there, we are going to talk about that. They can be separated by physical means, because a way by which you can separate seawater, we call it evaporation to dryness. Yes, you can use evaporation to dryness to actually separate that. When we get to our separating technique class, we are going to do justice to it. So you can see there are sea waters, which means that all all mixtures, see that all mixtures are impure substances. All mixtures are impure substances. Can you see that? All mixtures are impure substances, because when you talk about mixtures, you are talking about what contain. When you talk about mixtures, you are talking about what contain two or more constituents. Two or more constituents. Okay. So when you talk about mixtures, you are talking about something that contains two or more constituents, and they are what they can be physically separated because they are combined physically. You see that now? So if something is combined physically, it can be separated by physical means. So like salt and water, I combine them physically so I can separate them by physical means. And one of the way to separate is this evaporation to dryness. So which means all mixtures are impure substances. All mixtures are regarded as what? As impure substances. All mixtures. So let's take some examples of mixtures and see what are those things we have in there. Like air is a mixture. Can you see that? Your air is a mixture. And what are those things you have in air? They are mixture of gases. So we have oxygen in air, we have oxygen, we have CO2 in air, that's carbon dioxide, we have nitrogen in air, okay? We have nitrogen in air too. We have rare gases in air, we have moisture. So can you see? All this one now, they contain more than one type of atom or particle. So air is a mixture because it's a mixture of gases that are physically combined together. So air is a mixture. Let's take another one. You can have our milk too is a mixture. Yes, our milk. Our milk is a mixture. And what are the constituents in milk? We have water, okay? We have water, we have sugar, in our milk. We have fats there. We have fats. We have proteins. Okay, in milk we have proteins. Another thing, we have mineral salts in milk. We have mineral salts. We have vitamins in milk. So milk too, it's what? It's an impure substances. I want to believe we are still following. I want to believe we are still following. So our another mixture that we have, blood too is a mixture, which means blood is an impure substance in chemistry. Very funny, but that's the truth. Blood too is a mixture. Okay, blood is a mixture. Yeah, and what are those things we have in blood? What are those things we have in blood? We have water. Our blood has some kind of water. So we have proteins. We have proteins. Okay, we have fats in our blood. We have oil, we have sugar, we have a lot of things in our blood. We have our blood cells, our blood cells, we have our blood cells. Okay. What other things? We have enzymes too in blood. we have enzymes, we have our hemoglobin, too in blood. So you can see a lot of it like that. So our blood too is what? Is a mixture. Our blood too is a mixture. What other things? Yeah, we have our bronze too is a mixture. Please, you need to understand that we have bronze too as mixture. And what is bronze? Our bronze is an alloy. Your alloy is you are combining two or more metal together. So for all alloys that because bronze is not an element, it's not on the periodic table, it's an alloy. And in bronze, we have two elements in bronze. We have copper and tin in bronze. So we have copper and tin in bronze. So for our alloys too, they are what? They are impure substances because they are regarded as mixture. Petroleum too. Petroleum too is an example of mixture because in petroleum, what are those things we have there? We have petrol, we know that already. We have petrol, we have heavy oil in petrol, we have kerosene, okay, we have bitumen, bitumen, okay, we have bitumen too in petroleum, we have gas oil, and so on like that. So petroleum too is what? Is a mixture. Petroleum too is a mixture. I hope you are following now. So very, very important. We have all these things as mixture. We have a lot of them. We have seawater. I have talked about that. Seawater too is a mixture. Even our urine, yeah, is a mixture and is an impure substances. So that's the reason why you cannot base impure substances to what is clean or what is dirty. No, you will be wrong. So I've given you the properties to know if something is pure and it's impure. So your urine is an impure substance. Why? Because our urine is a mixture of urea, that's a compound. It's in our urine. We have water too. Okay, we have water too in our urine. We have mineral salt too in our urine. So I tell salty, that's why I tell salty. We have our mineral salt in urine. So our urine too is an impure substances. I hope we are getting that. Our palm oil, very our palm wine, rather. Our palm oil, very funny. It's an impure substance. That's very funny. Our palm wine, not palm oil, palm wine. Our palm wine too is an impure substances. Yeah. And why do we say it's an impure substance? Because it contains water, okay? It contains sugar, it contains alcohol, a lot of things there. We have it contains mineral salt too in our palm wine. You have vitamins there too. You have vitamins there too. Okay. We have proteins and etc. there in our palm wine. So our palm wine too, it's what? It's a mixture. So for everything that contain more than one type of atom or particles, then we said it is what? It is a mixture. So all mixtures are impure substances. So, but what about sand? Is sand a mixture? Definitely no. Because our sand, the chemical formula for sand is silicon dioxide. Can you see? And for you to have even been able to write the molecular formula is a pure substances because this is a compound. And we have learned that all compounds are what? Are pure substances. So for anything that you can even write the molecular formula, it's a pure substance. It's a pure substance. So this one is pure substance. What about washing soda? Washing soda. Washing soda. Washing soda, the molecular formula is Na2CO3. Can you see? For you to have been able to write the molecular formula, it means it's a pure substance because this is a compound. And we have learned that what are all compounds are what are pure substances. I want to believe we are getting this. So all pure substances are elements, all pure substances are compounds, while all mixtures are impure substance. So let me quickly do this. So for pure substances, for reminder, note that for pure substances, we have, you know, all elements will be grouped under pure substances, and all compounds will be grouped under pure substances. I want to believe this is clearer. So for all impure substances, okay, for all impure substances, we are going to be having them grouped under what? Mixtures. So all mixtures are impure substances, while all elements and all compounds are pure substances. I hope that is clear. All elements, all compounds are pure substances, while all mixtures are impure substances. I hope that is very, very clear. I hope that is very, very clear. So, very, very important. We can have our mixtures too. Very important. We can have our mixtures based according to what they contain. We can have our mixtures, we can have our homogeneous mixtures, and we can have our heterogeneous mixtures. So for mixtures, we'll continue the grouping from here. For mixtures, we can have what we mean by homogeneous mixtures. Homogeneous mixtures, and we can have a mixtures that is heterogeneous. Okay? So homogeneous means they are the same. Heterogeneous means they are what? They are different. So we can have an homogeneous mixture, and we can have different. So different. So we can have an homogeneous mixture, and we can have an heterogeneous mixture. Very important. We can have an homogeneous mixture, and we can have an heterogeneous mixture. So let's take example. What are the homogeneous mixtures we can have? Let's quickly do that before we call it a day in today's class. So your homogeneous mixtures, let's see homogeneous mixtures. Our homogeneous, our homogeneous mixtures. Okay? Our homogeneous mixtures, meaning they are what? They are the same, they are existing in one phase. That means that's the same. So I can have gas in gas. That's homogeneous. Homogeneous means gas in gas. What are example? We can have e.g., air is a mixture of gases where you have oxygen, you have nitrogen, you have rare gases, you have all that. So gas in gas, an example, air is an homogeneous mixture. So we can have liquid too. We can have liquid, we can have liquid in liquid. We can have liquid in liquid, meaning I can have kerosene mixed with water. That's an impure substance, it's a mixture. So kerosene is liquid, water is liquid, so we can have it like that. So they are homogeneous. We can have solid in solid too. Solid in solid. Solid in solid, and a good example, I think I've given that, that's our alloys. That's our alloys, like our brass, like our bronze. I've given that, like our bronze that has copper and tin. So that all these ones I mentioned, they are homogeneous mixtures. They are homogeneous mixtures. So we can have heterogeneous mixtures too. We can have heterogeneous mixtures. We can have heterogeneous mixtures. And what heterogeneous means? Different. So heterogeneous means different. So they are not in the same phase. We can have an heterogeneous mixture. And let's see examples. Let me just give few examples. You can have gas, you can have gas liquid mixtures. You can have gas liquid mixture. So you can see gas liquid is heterogeneous. And a good example is our aerated drinks. Our aerated drinks. Your beer, your Coca-Cola, all these are carbonated drinks. Your beer, your soft drinks, uh, your soft drinks, your soft drinks, your beer are in this category. So they are they are mixtures. Okay, you can have liquid in solid. You can have liquid in solid. You can have liquid in solid, and a good example is our what? Our sand sugar solution. You have sand sugar solution. Solution means water is there. So you have water, you have sand, you have sugar. So the water is acting as the liquid, while the sand and the sugar is acting as the solid mixed together. So they are heterogeneous mixtures. And we can have our gas, we can have gas in solid. Gas in solid. What are the examples? Amatan is an example. Yeah, gas in solid. Amatan is an example of gas in solid. You have solid particles suspended in air too. You have solid particles suspended, suspended, suspended in air. So we can have all those ones as mixtures. So very important, you need to know that you can have homogeneous mixtures, you can have heterogeneous mixtures. I hope it is clear. So have it in your mind that for anything that you want to regard as pure substances, okay, they are all elements are pure substances, all compounds are pure substances, while all mixtures are impure substances. I hope that is very, very clear. So let's go back to our question now. Let's go back to our question. Which of the following is an example of what is an example of a mixture? So common salt, blood, sand, washing, soda. So you should be able to give the answer now. Our common salt, that is sodium chloride. And sodium chloride is what? It's a compound, meaning all compounds we know they are what? They are pure substances. So common salt is not the answer. Can you see that? Blood, is that which of the following is an example of mixture? We know mixtures are what are impure substances. So the correct answer there is blood because we have said it in our examples that blood, in blood you have your blood cells, you have your what proteins, you have your proteins in your blood. We get that examples. You have hemoglobin, you have fat, you have sugar. So blood is the answer. Let's go to sand. Is sand a mixture? No, because the chemical formula for sand is what is silicon dioxide, that's SiO2. So it's not a what? A mixture. It's a compound and it's a pure substances. Can you see that now? So very, very important now. Very, very important. You can see that the correct answer there is what? Is blood. It is blood that is a mixture. The correct answer there is blood because they said which of this is not a mixture. So they said common salt, said common salt. Common salt is a compound because it's sodium chloride. Can you see that? Common salt is not a mixture because mixtures are impure substance. For blood, I've said that before, it contains a whole lot of things like that. We have mentioned them. It contains your fat, it contains water, okay? You have protein there. Can you see that? You have protein there. You have enzymes and a lot of things there as cited in my example. So blood is the correct answer. Blood is the correct answer. You know your sand, that's silicon dioxide. For sand, that is what? Silicon dioxide. Okay, so this is a compound. So it's for all compounds and all elements, they are what? They are pure substance. While our washing soda, that's Na2CO3. That's your washing soda. This washing soda. That's the chemical formula for washing soda. Okay, that's washing soda. We can have caustic soda too. Yeah, so caustic soda is sodium hydroxide. So if you are seeing that NaOH, that's caustic, that's caustic soda. We can have baking soda too. That's NaHCO3. That one is baking soda. All these things are pure substance because they are compound. I hope that is clear. So don't forget, for pure substances, all elements are pure substances. Okay, all mixtures, all elements are pure substances, all compounds are pure substances, while all mixtures are impure substances. I hope we get that. Let me say that again. All elements are pure substances, all compounds are pure substances, okay, while all mixtures are impure substances. I hope that is clear. All mixtures are impure substances. So very, very important. We should understand that. So let me just give a question. Let me give a question and see. So you can just stop the video after you have seen the question and tell which of the following is the answer or which option is correct. So the following, let me just give this. The following are pure substances. Pure substances except following are pure substances except A, water, B, salt, sodium chloride, C, brass, brass, D, D, oxygen gas. So let's see. You can pause the video and choose the correct answer before I will now do the correction. So very quickly, what's the correct answer? Let's see. Water is a pure substance, right? Because you can even write the formula for water. That's H2O. We know that already. So water is a pure substance. Salt is a pure substance. Oxygen is a pure substance because it's an element. And we have said all elements and all compounds are pure substance. So the correct answer here is what is brass. Can you see that? Because brass is an impure substance. And why is brass an impure substance? I've said that in the video because your brass is what? Is an alloy. It's not an element. It's an alloy. Okay. And in brass, what are the elements you have there? What are the elements you have there? You have copper. You have copper in brass. You have copper and what? And zinc. So these are two different elements combined physically. You can see these are two different elements combined physically. If they are combined chemically, it would have been a pure substance. But because they combine copper and zinc physically, okay, that's the reason why the answer to the question is what is brass. Brass is an alloy, it's not an element. You can't find brass in the periodic table. It's not an element, it's an alloy. And we have said all alloys are impure substances because they are combination of two or more metals physically. So very, very important. We should know that. So the summary of the class is all pure substances. If you want to know pure substances, if it is an element, it's a pure substance. If it is a compound, it's a pure substance. But if it is a mixture, it's an impure substance. I want to believe today's class is very, very clear. If you have any question, you can drop it in the comment section box. But I want to believe the class is very, very clear. Thank you very much, T. I'll join you in the next class. See you. Thank you.